In this video, we're looking at combination factoring, which is kind of looking at factoring as a whole versus the individual processes. So this is really helpful for the test of kind of a unified approach to looking at factoring. It's also how you'll encounter factoring as you use it in your future math classes, where it's going to be all jumbled together. So if you haven't already seen the factoring flow chart, it's on the weekly modules, and this kind of lays out my overall strategy of how I approach factoring. So you can find that there or pause and write this down. So most important thing first is no matter what type of factoring, you should always try to factor out a GCF first. That's going to make your life a lot easier if you can get into that habit of always taking a look. A lot of times it won't work, but you do have to try. So the key thing here in this approach is everything is to try. There's no guarantee to work, but this just gives you an overall approach. So that you're consistent from problem to problem. You can't control what works, but you can control what you try. And so the first four examples that we're going to look at, I just want to focus on one pathway so that we can see that unified approach. And so the first four problems, we're always going to factor out the GCF, and then we're going to follow this path down here to see the different things that can happen following that pathway. So looking back at problem number one, starting out looking at a GCF, those are both even. So I see that I can factor a 2 out of there. So that gives me 2 times x squared minus 25. So I think of the GCF factoring as kind of moving stuff out of the way, clearing stuff out so we can see the structure that's left here. So looking at x squared minus 25, there's two terms in that. So I'm going to try difference of squares. So the trying part is it's minus, so it's a difference. Those are each perfect squares, so I can break those down with difference of squares. So that parentheses can be further factored into x plus 5 and x minus 5. So that would be my answer there. We've turned this primary subtraction relationship into a relationship of multiplication as the primary relationship. That's what it means to factor. So we've joined those with multiplication. So in terms of this pathway here, this first example is where we got something on both of them. We were able to do a GCF and able to do difference of squares. So you don't have to write this down, but just for the record here, I just want to put that we did GCF, difference of squares, and we're successful on both. So looking at the second example, we also start out again with the GCF. They're both even, so I can take a 2 out. And so that gives me x squared minus 26. So we're still trying a difference of squares. And we're optimistic because it's difference. So there we go. But 26 now is not a perfect square, so we're not successful here, but we tried. Erase that. Awkward erase there. So this is all we can do. That is as far as we can factor that. So this had a GCF, but no difference of squares. Looking down at example 3, GCF first. You might be getting sick of that. So in this case, we've got our initial factoring as 2 times x plus 25. So that's start of factoring because it's written as a product. Now we have two terms, so we're trying difference of squares, but that's a plus, so it's not a difference of squares. So that's as far as we can take it. There's no sum of squares. There's nothing further we can do if that's a plus. So that gives me GCF, no difference of squares. So then looking at number 4, there's no GCF in this case. There's also no perfect squares, even though we have the minus and the 2 terms. So we're trying difference of squares, but neither of those are perfect squares. So this one, there's nothing we can do. So our answer here would be not factorable. So I'm just realizing here I left off one of the pathways, which is, let's say that we want to factor something like 25x squared minus y squared. So bonus question here. So in this case, we would try the GCF, but there's no letters in common. This doesn't have a number. So we tried it. Sometimes it's just a quick check and it's almost intuitive where you just see like, oh, that doesn't work very well. So we tried, didn't work. Then because we have 2 terms, we're looking for different squares and we can break that up. So this would be 5x plus y times 5x minus y. So that would be an example of the pathway where there's no GCF, but difference of squares works. So you can see, on the one hand, you could look at all those examples as being different, but kind of this unified approach is that we can't control what works, but I would claim all of those problems are the same in that we tried GCF first every time. We tried difference of squares second, and kept going through that pathway. And so that can help you try to break down that uncertainty of like, every problem's different, or what do I do? Is that we always have this guideline of what to look at. So I have a couple other examples where we will follow some different paths on our flow chart. So if I want to factor this right here, I have a GCF. In this case, we have a 10 we can pull out and an x. There we go. So I'm left with x to the 4th minus 16. Now I still have 2 terms. So I'm looking for difference of squares. Difference, that's a square. Even though this isn't an exponent of 2, that's still a perfect square, because x squared squared is x to the 4th. So I can break this down into x squared plus 4 times x squared minus 4. This is one of my favorite factoring problems. No guarantees, but often when I say something's my favorite, it finds its way to the test, because it's still my favorite when I make the test. What I'm trying to highlight here is this statement at the end, which is that before you call the problem, you want to see if there's any other factoring you can do. So looking back at this, our initial breakdown created those 2 things I have highlighted. This green factor is another difference of squares. It's minus. Each of these is a square. So this is not factored completely and broken down completely until we have broken this down. But the reason this gets my favorite question status is not only do you have to recognize that this can be broken down further, but you have to show restraint and know that this one cannot be broken down further. As tempting as it is, this is a sum of squares. There's no sum of squares factoring. So we have to hold back, leave that be, but then do the difference of squares on that green piece. And that creates our final fully factored form. All right, so last set here. So in problem number 6, we have that GCF. And what I want to point out here is that you might look at this problem and start doing the AC method, which is our method for factoring when we have this number in front. And sometimes we have to do the AC method, but this example, the point of this is to always try that GCF first And the advantage to that is sometimes there are problems that look like the AC method, look like that really long type of factoring. But if you clear the mess out of the way first, it could be a fake AC method. So I'm noticing these are all factors of 3. So I'm going to pull that 3 out. And now I have x squared minus 4x minus 12. Now this is just a regular trinomial factoring. So the 3 just hangs out. And now I'm looking for a product of negative 12, a sum of negative 4. So negative 6 and 2 works there. And because we just have a plain x squared in green, that means when I break that down, x is going to lead in each of those parentheses. So I have x minus 2 or x minus 6, x plus 2. So that can create our factoring. And if you miss that and do the AC method, you'll have a longer factoring, but then you're also going to have to pull that 3 out eventually. So it really makes things easier if you do this first, and it'll make that second factoring easier. Okay, last example. So looking at this, I'm always trying for a GCF. We've been very successful in that in this video, but we don't have any letters in common, and this doesn't have a number. So our pathway in this problem, we tried this, we failed, but we tried. So now when I look at what to do next, I'm counting the number of terms, and I've got 4 terms here. And so our flowchart says, hey, if you have 4 terms, then try grouping. So I'm following down here. And so when I try grouping, I am picking first 2 terms and taking a GCF out of those. So I see a 9 and an x squared for those first 2. And then for my second 2, I am taking the sign in between. So I'm taking this minus, factoring that out. And then I also see there's a y squared in there. So I've got y squared and then y plus 7 left. So this can be kind of a tricky factoring. Sometimes I just kind of do a quick mental check of just what's in light blue there. That minus y squared times y gives me minus y cubed, but then minus y squared times plus 7 gives me minus 7y squared. So even kind of in the middle, I can check that I'm on the right path by doing that breakdown. And so another kind of hint is that if these 2 wind up being the same, I'm pretty sure I'm on the right track for a factoring by grouping. So I finish this off by noticing that these 2 factors are now a common factor in this piece. So I can pull that out. So I have y plus 7, and then what's left is 9x squared minus y squared. So going back to our flowchart, I tried grouping. I was successful. There we go. But now I need to see, before I call it, I need to see if there's any other breakdown I can do. And so as I look at what's here, I see that this has 2 terms and it's got some exponents. So I'm looking at that with 2 terms as another possible difference of squares. And I see that all of those are perfect squares. So I can break that down into 3x plus y times 3x minus y to break down that red piece. And so that gives me my final results. right here. So hopefully that gives you some options. And always, I guess the short version is always use the flowchart.